All right, folks, I got a simple harmonic motion example for you to try. If you need a moment, please take a moment to pause the video and kind of just write all this information down. All right, so hopefully you've written the example down, the picture and all this, and let me kind of explain what's going on here. So you got a cart that's bobbing back and forth on a spring between these two endpoints, and this point here is equilibrium. Um, to the right is positive, and let's say the period of oscillation is 4 seconds. So remember, one full cycle would be, if I'm starting here, how long does it take to get back there to the same spot? So I go back and forth, that would be one period, okay? And here's what we're going to determine. We're going to determine the position, velocity, and acceleration, all as functions of time. We're going to also determine the Vmax and the Amax, all right? Now, the rule for well, it's not really a rule, but normally in class, and what I'd like you to try to do is I'd like you, before you continue the rest of the video, I want you to try it yourself. And what I always tell everybody is, to just so that we all agree on the form of our answer, let's use a cosine function for x, and let's make sure the coefficient, the amplitude, let's make sure there's a positive number out there, so there's no negative in front of the cosine. So I would suggest, seriously, pause the video for a sec and actually try this out. See if you can write all this stuff, these three things as functions of time, and then write these out. All right, did you try it? If you didn't, pause the video and try it. Go ahead and try it. All right, so hopefully you tried that. All right, so here's what this is going to look like, okay? We know in general, x equals a cosine of omega t plus phi. Okay, so I got to fill in all the blanks here. Well, the amplitude is easy. That's 4 centimeters, right? That's how far the thing gets from equilibrium. And if you want, you can just leave this in centimeters, and we'll make x will be in centimeters, okay? Well, what's omega? Well, omega is 2 pi over the period. So for us, that's 2 pi over 4, which is pi over 2. So that's your omega. Now, what's your phi? Okay, well, when we started our watch, I said the starting position was left. Okay, so xi is negative 4 centimeters. Okay, now what do I make this so that cosine is equal to negative 1? Because I need the negative sign out of the cosine. I've already got the 4 sitting here. I need a negative sign. Well, cosine of what angle is negative 1? Well, pi. Okay, so our answer here would look like this. X equals 4 cosine of pi over 2t plus pi. So that would be your velocity or position as a function of time. Now, the rules I asked you guys to write as a cosine term and to make sure the coefficient out front is positive. There are at least three other ways we could have written this. You could have written negative 4 cosine of pi over 2t plus 0. That would also work. You could have written 4 sine of pi over 2t minus pi over 2. Or you could have written negative 4 sine of pi over 2t plus pi over 2. And there are other things you could have written too. Like here, we could have written plus 3 pi over 2 would be the same thing, and so on. Okay, so there's lots of ways to write this. But I asked you guys to write a cosine and a positive in front, which limits us to this answer that we got. Now, for the rest, you just take a derivative. So the velocity is dx dt, which would be 4 times what's in front of t. So that becomes a 4 pi over 2, which becomes a 2 pi. The derivative of cosine is negative, okay, sine. And then the inside doesn't change. So you got pi over 2t plus pi, okay. And then our Vmax is whatever the coefficient is in front of that, which would be 2 pi, okay. And then we got acceleration, which would be dv dt, which would be the derivative of this. So we got negative 2 pi times pi over 2. You end up with negative pi squared, and then derivative sign is cosine. and then you got pi over 2t plus pi, and A max would be whatever the coefficient out front there is, which would be pi squared. Now, by the way, both of these would be in centimeters, so this would be centimeters per second, and this would be centimeters per second squared, okay? Something to note here, omega is pi over 2, right? So Vmax is omega times x. So it's 4 times omega, which is 4 times pi over 2. And Amax is A, the amplitude, times omega squared, which is 4 times pi squared over 4, which is your pi squared. So that's another way to figure out the Vmax and the Amax. Okay. All right, well, I hope that example was helpful, and thank you very much.